Hi, I'm Majid Lenin. Welcome to the Enterprise Architecture video series, part 70. We are talking about the 6-layer framework for establishing enterprise architecture. And last few weeks, we've been spending time on architecture domains layer. And last week, we started on the application architecture. So we'll continue on the application architecture and also touch upon the architectural styles and patterns a bit in this week's video. Let's start with application architecture. Last week, we looked at the macro components of the application architecture, which is the application landscape and the functional architecture. And this week, we'll look at the micro components, which is application data model and the application component architecture. These are, I don't want to go very deep into this because these are common knowledge across how do we do the application data model and the component architecture, but I'll just touch upon so that I can complete the storyline, right? So to start with application data model, let's look at what is application data model, right? So application data models are either physical or logical data models that realize the structural aspects of the business objects or policy objects, right? The reference data that goes with the policy object. So we looked at in the information architecture how we get the business objects and the policy objects defined. And for all the business objects and the policy objects, we looked at how within the application landscape, how do we map them to the respective applications and which application is going to manage those business objects or the policy objects, right? So when we pick an application that deals with that business object or implements that policy object, we need to translate that into a logical data model. And at a later stage, so we'll define the logical data model when we are at a higher level of enterprise architecture. And when you go into the onto the depth, right, we can expand that into a physical data model. And logical data model doesn't really depend on the technology choice, but when you get into a physical data model, it depends on the technology, right? Are we going to go with an object database or a RDB mesh, right? Or are we going to use a graph DB? In today's world, there are a lot of use cases coming up for graph DB, right? So it's based on that physical data model changes, but when we define at a higher level, the logical data model is really the same. Data model also should define the cacheability of the data, right? Sometimes it's needed for the data which is managed by an application to be cached, to be used by another client application, right? So the cacheability of the data, what elements can be cached, how it can be refreshed, can be defined as part of the application data model. And the scope of the data model, as I said, it is limited to that application, right? So I don't want to go further deep into it. This is then all common knowledge of how do we build a data model, etc. Are common knowledge, right? Let's go into the application component architecture, right? So what is application component architecture? Again, it's pretty common knowledge, right? So it's basically breakdown of the application into building blocks or functional blocks or functional or non-functional blocks, right? So the key thing I want to specify or bring to the focus here is that this is the layer, this is the place at which we're going to start introducing the non-functional architecture. So far we've been talking about how we build the business architecture, how we get to the information architecture, and then we are getting to the application architecture. So it's a journey of how do we translate a set of business requirements into IoT components, or right? Now, this is the time when we actually build the component architecture for the application. We'll start looking at the non-functional requirements, right? So the non-functional requirements are basically things that we need to take care for the application to be operationalized, right? So we will look at a little more deep into the non-functional architecture in the upcoming slides. So this is where we'll start building an apart. So application, when you break it down to functional and non-functional building blocks, right, we can use, it is always useful to have a set of reference model. Just like when we looked at the application landscape, how we can have a set of reference model to define the landscape, right? We can use for each application, we can use the reference models as well. So when we at a higher level, we can actually define the reference model, which can be later picked up by each application. Based on the type of application, we can accept the reference model. So there could be more than one reference models. So when we break it down to these functional or non-functional building blocks, it is better to align to some set of reference models and pick what reference models best fit into for the application, right? So we'll look into the reference model in the next slide. So the key thing we need to remember here is this is the place where we introduce a non-functional architecture. So this is a very important component of the application architecture. The non-functional functional requirements are the key things that would get translated when we go into the technical architecture, right? So let's look at the reference models, right? So I listed out a couple of sample reference models. It's just for illustration purpose. So a typical web application, we will have a UI layer, we have web services layer, and the core business capabilities can be a set of microservices into the microservices layer, and you have a persistence of the DB layer, right? So when we define that as a reference model for a web application that could be in the application landscape. So there could be more than one web applications within the landscape. So those applications can adopt the same structure as such. But when we define that, this gives us within the reference model itself, it gives us an opportunity to define the non-functional requirements of the architecture, right? So in this particular example, it could be the content delivery network. It could be the web server or HTTP servers, the need for an HTTP server, need for a logging framework, need for encryption, monitoring framework, and there may be a need for in-memory cache, the reporting capabilities, right? So these are non-functional requirements that can be identified that any application or any web application in this particular example need to carry when it is operationalized. So this reference models help us to identify the common non-functional requirements and also what are the technical frameworks that can be standardized, right? So when we identify this, we know that there is a logging, in this particular example, there is a logging framework needed, right? So we can have a common implementation across applications for that framework. And it also helps in identifying when you go into the technology architecture, it helps us to identify the technology choices for those building blocks, right? So so in this case, we come to know that there is a microservices layer needed. So what is the technology we need to use, right? What kind of container technology I want to use, etc. would come in when we go into the technology architecture. And it's standardized, so reference model standardized the application component architecture across the landscape that we saw, right? There could be more than one web applications within the landscape. All of them can actually adopt the same reference model. It helps in simplifying the operations. And the second example I have is the workflow management. So if there is a workflow management need, how the application needs to be architectured or organized, right? So typically there would be a set of APIs that give access to the read and write APIs into the workflow. A workflow UI is needed, and the workflow engine, which is the core engine that needs to drive the workflow forward, and it needs to listen or publish to a common message queue, right? So it can receive a list of events or publish a list of events to communicate to the application, the external applications, right? So this could be a typical reference model for a workflow management application. And just like web application, a particular application landscape and enterprise can have a number of workflow management applications. So all of them can actually choose to have a simpler architecture. So now let's look into the non-functional architecture, non-functional requirements, right? Again, it is common knowledge, right? We don't have to elaborate into what it is. So these are capabilities that applications should exhibit, but not directly related to the functional requirement that we capture in the business architecture. But it is needed for delivering those business business capabilities and operationalizing the application, right? So typical things like logging, load balancing, alerting, encryption, caching, right? Say, clickstream analysis. So there could be a bunch of non-functional requirements that could come in. And it is again depend on the organization, what non-functional requirements the organization is putting forward, right? It drives the technology architecture and helps in the choosing the technology, right? So if you want to do logging, what kind of technology you want to use for logging, etc., right? And it basically eliminates the gap. So a lot of times, if we don't capture the non-functional requirements, right, we'll have gaps when we actually when we just implement the business capabilities that is required. When we operationalize or productionalize this application, we may end up being a lot of gap in other operational procedures, right? So this capturing the NFR is very important so that when we take the application into production, we have a smooth journey, right? Each of the NFR, whatever we identify for applications, say once we list out this list of, we have a list of catalog of NFRs, we need to map them to the respective technology component, right? So that's where it helps, right? So we make sure when we define the technology architecture, we have each of these NFRs covered in that, right? And quickly we'll touch upon the architectural styles and patterns a little bit. And after, once we cover all the 6 layers, we'll go into details of, we'll pick up few architectural styles and patterns and go in depth. But today, I just want to give an introduction into architectural styles and patterns to complete the storyline, right? So let's start with architecture styles. Again, not it's very common knowledge on architectural styles and pattern, right? So I have listed out some of them. So one key thing I want to stress here is what is the difference between architecture styles and patterns. So in my view, when we say architecture style, it is a broad approach that serves as a reference for architectural decisions, right? So it would be a very broad way of doing things in the enterprise architecture, right? Primarily, it is applied to the macro level decisions, right? Not at the micro level or within the application decision. It's about across application decisions, right? That's where the architectural styles generally come into play, right? Few examples are layered architecture. So how do we break down the entire enterprise into layers, right? Based on business or IT capabilities. Pipes and filters, this is primarily towards defining a data pipe where data gets enriched or filtered out when the data flows through a pipeline, right? It's typically for any kind of a production kind of a scenario, right? Or like maybe a catalog kind of scenario where I have a product catalog where I take the product through a life cycle where it gets enriched through this pipeline, right? So it could be any scenario like that. Service-oriented architecture, I don't have to elaborate. So this is the typical architecture we follow across the world today. Event-driven is another style we follow across the world today, right? Where applications basically generate and respond to events, right? Rather than calling its applications and have a tightly bound architecture. This is more like building into a scalable architecture, right? Publisher subscriber is very related to event-driven, right? So where we loosely couple the applications, where applications just publish or subscribe to topics on a generic event type, right? And domain-driven architecture is a common practice today. So breaking down the lines into set of domains, it could be IT domains or business domains. So these are typical styles we follow, right? I mean, an organization or enterprise can pick n number of styles based on the scenarios and how the application landscape is, right? We'll get into, as I said, once we finish the 6-layer framework, we'll go into specific styles and patterns and discuss more on it. Then when it comes to architecture patterns are repeatable solutions. So that's the difference between style and patterns, right? It's a repeatable solution for a specific architectural problem statement, right? Whereas style is more of a broad guideline kind of or a reference model kind of a thing, whereas architecture pattern is a repeatable solution for a specific problem statement. And it can be applied at a macro level or a micro level. So I've listed some of the macro level patterns. So API gateway is a typical macro level application architecture pattern, the reverse proxy pattern we use for scalable and secure architecture. In-memory cache is another architectural pattern where the client applications need high-performing access to the DB, right? So where we cannot really go down and get it from the persistence layer, right? So that's a typical pattern we use nowadays. Centralized logging is another pattern we use across where we have a centralized infrastructure where all the logs across the applications come into, where we can actually build on the better traceability. It gives analytics capabilities. It gets enables us with proactive care, right? So all these are macro level architectural patterns. Micro level, we have serverless architecture. So wherever we don't need real-time high-performing infrastructure services, we can actually look at serverless implementation where the resource utilization is optimized. Similarly, microservices, wherever we want to go to distributed scalable architecture, we go with microservices. So these are a couple of micro level architectural patterns, right? So we'll get into the details later. And just to summarize what we looked at today, it's like we looked at application data model, application component architecture. We looked at what are the reference models, some of the reference models, non-functional requirements. And then we touched upon the architecture styles and architecture patterns. The next week, we'll look at the technology architecture on the architecture domains, and then we will move down into the other layers of the 6-layer framework. Thank you.